Good morning, Algebra 2 students. For Mr. Fry, I'm looking at the quiz over families transformations and two variable inequalities. And I wanted to give you some accommodations, some clarifications. So for the following problem, fill in the table with the description of what each transformation does to the graph of the parent function. Here we have the parent function, x squared. So we have a quadratic function going on here. It's going to be U-shape, centered right in the kind of that looks like this. This is what x squared looks like. And so, we have our y-axis. This is our y-axis. This is our x-axis. So how does this x squared move? And I'm going to give you choices. And these are your choices, and they are all out of order, and there's extra ones. There's two extra ones on there, too. So just be aware of that. You're going to use these once, and then there's two extra. So here we go. So if we have the parent function of x squared, and the new equation is x squared plus 2, what's going to happen there? Is that going to be, what kind of transformation? Is that horizontal right, horizontal left, vertical up, or vertical down? I'll tell you what, I'll do that for you. I will give you, it's going to be one of these. Kind of split this up. So remember, horizontal is, along the x-axis, it's moving this way. Vertical is the y-axis, moving up and down. And then when you get to description of change to graph, so if you're saying it's going left or right, or you're saying it's going up and down, how much is it going up and down or left and right? You can explain that, and on what axis is that, So if it's vertical, it'll be y. If it's horizontal, it'll be the x-axis. So a little description there. You may be able to use the coordinates, like, you're going to take your x coordinate and you're going to add 2 to the y, or you're going to take the x coordinate, you're going to add 2 to that, and then you have the y coordinate. You could explain it that way too. So that's the description of change to graph. Okay, I'm not going to do that for each one of these, or else this would take forever. So then you have x squared minus 3. Okay, and here are your choices, and it's in the top. It's either going to be horizontal right, horizontal left, vertical up, or vertical down. Then you have in parentheses x minus 4 parentheses squared, and that's going to be one of the top 4 here: horizontal right, horizontal left, vertical up, vertical down. And you pause this as needed. And then you have x plus 2 in parentheses squared. And that's going to be one of these top ones too: horizontal right, horizontal left, vertical up, or vertical down. Okay, so for the last three are one of these, okay? So we just have negative x squared. So the parent function is x squared, and then just throw in a negative in front of it. What is that? What is that called? Vertical compression, vertical stretch, reflection, horizontal stretch, or horizontal compression. 2x squared, so you're just taking that parent function and putting a 2 in front of it. What is that? Vertical compression, vertical stretch, reflection, horizontal stretch, or horizontal compression. Then you have half x squared, and that's going to be vertical compression, vertical stretch, reflection, horizontal stretch, or horizontal compression. Once again, your descriptions then explain, how much it's stretching or compressing, or explain the reflection over what axis would that be. That would be your explanation. You could also put the x and y's and how that would look in your description if you want to go that route. Okay, going on to number 2, match the equation with the described transformation if the parent function is x cubed, so x to the third power. Okay, so we just have x to the third power. So let's take a look at this one. You know, we have a vertical, or I'm sorry, I almost told you what's going on here. Anyways, take a look at these, how x cubed has changed, all the stuff that's been added to it. And then, you know, just match your A, B, C, D with these. So, you know, look for the one that's shifted left 3 units and then shifted up 2 units. And that's going to be either A, B, or A, B, C, or D. And then look for the one that's reflected across the x-axis and the vertical stretch of 2. Okay. Some of these answers might help you with your graph, or your table on the previous page for number 1, because you might see this and say, oh, okay, I see that there is a, you know, there's this in front of that parent function, and that's what it's causing it to do. That's what it's called. It's a vertical stretch. That's what the vertical stretch is, or that's what the reflection looks like. Okay, so you can go back and change those answers if this helps you at all. So some of these answers may help you. Look for the one that has the vertical compression of a half. Okay, that's going to be pretty easy. Shifted right 3 units, and then shifted down 2 units. And then look for the one that's just simply shifted right 1 unit. Number 3, graph the following 2 variable inequality. You're going to have to get y by itself on one side. So when you do that, you have y is going to end up greater than or equal to x, and I'm adding 5 to both sides, so you have x minus 2 plus 5. Put these two together, and you'll get the, you'll get x is greater than or equal to, or y, I'm sorry, is greater than or equal to x, whatever that number is. That's going to be your y-intercept. Okay, remember that's your y-intercept. And this, you don't see anything there, is your slope. Okay, and since there's 1x there, that's, you know, a slope of plus 1. Okay, so then you could just, you know, simply sketch this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Find this y-intercept, okay, if it's positive or negative, you know, find it on your y-axis, put that point there, and then just sketch a line, you know, going up 1 over 1, put a point, up 1 over 1, put a point, up 1 over 1, put a point, from where you start with the y-intercept, okay? Number 4, when do you use a dashed line when graphing 2 variable inequality? And when do you use a solid line? Okay, here is going to give you an example of, you know, when you use either a dashed or a solid line. So you got to make sure your line is either dashed or solid, okay? And you could use these symbols to signify when you're going to use a dashed line, when you're going to use a solid line. Okay, and use that in your explanation for number 4. And I think that's it. It's a short quiz. Okay, good luck. Hope you do well.